So without further ado, I've started the recording. Let's continue from where we left yesterday. That is regression machine learning. So as I've already mentioned, we have 6 to 7 slides approximately to cover before we can start with the practical. So for those of you who want to do the practical along, though the session will be available on YouTube, you could do it along with me. So please get your laptops ready if you have joined from a phone and you're interested in doing the practical. If you just want to watch me do it, by all means, I'll be doing it. You can ask me questions if you have any. Okay. So regression machine learning. I know I did discuss the slide yesterday, but I want to start from this again. Just one overlapping slide. So regression is a machine learning technique used to understand relationships between variables and predict numeric labels based on features. It is a supervised learning technique. So first thing to note here, wherever you see the word regression, because there would be questions around, regression for sure. So just remember that regression is a form of supervised learning. So we did discuss supervised and unsupervised. In supervised, we have controlled the data set that goes into the input, and in unsupervised, we have, so the data set is not monitored by us. The input is not monitored by us. The machine learning capability has a lot that it could, learn outside. So the probability of things going south is higher with unsupervised, but at the same time, the knowledge gained is much more. Whereas in supervised, for a general use case, the knowledge that you gain is going to be, kind of what you feed it. So the more you feed, the more it gets. The less you feed, the less it gets. But at the same time, since it's supervised, uh, the accuracy, or let's just say, machine doing what you want it to do, that probability goes very, very high. Okay. So going forward with the definition, this involves training a model using data that includes both features and known values for the label. Regression models are widely used in many industries such as real estate, agriculture, and marketing to predict outcome based on specific characteristics or features. Wherever you see a question in the exam where they're asking you to predict an outcome, that if this will happen or this will happen, you are looking at an example of regression machine learning. They would be asking you what comes inside regression, what comes inside the next category that we talk about. So wherever you see anything is being predicted related to, where you're trying to uh, get something numeric, you are looking at regression. So the next thing is, what are the steps that are required in regression? So to train and deploy a regression machine learning model in Azure Designer, you need to prepare the data, train the model, evaluate the performance, and deploy the predictive service. So this is the service that we'll be using. But other than that, what you need to do is you need to get your data set, you need to train the model, you need to evaluate the performance. This is something which we would be doing, something similar which we'll be doing for the custom image practical that we have, custom vision practical that we have basically. But that what will be different is we'll provide the data, we'll train the model. We do not need to evaluate the performance, though we can, and then we obviously have the option to deploy it in prod if we want to. So you'll get more about that. Now, when we do the practical, it's going to be a little time consuming because we have two practicals. So, models can take anywhere between 15 minutes to 20 minutes to train, though Azure claims it takes about an hour. But I trained one in the morning just to, and get an idea how long it will take for us to do the practical. And from my analysis, it's not more than 10 to 15 minutes. Uh, Other than that, something that I'll talk about is when we create our resource for custom vision, the resource creation might take 10-15 minutes. So, I would want everyone to have downloaded the files at least by then so that we can have the, best utilization of the limited time we have. If it takes more time to solve the practical, I might reduce the time for the break, but I hope everyone will be fine with it because at the end of the day, you're learning something which can be really helpful and beneficial for you in the future. Going forward, Azure Designer has pre-built components. So we're looking at pre-built components for data preparation and model training. You can evaluate the model's performance using metrics such as mean absolute error, root mean squared error, relative squared error, relative absolute error, and coefficient of determination. Now, it's not something which is commonly asked in the exam, but I would say if you can, just make some notes around this and just have a look at them before you go into the certification, because they might be asking you terminologies about mean absolute error, mean root squared error, relative squared error. You do not need to know what they are. All you need to know is that these are certain methods which can be used to evaluate a model's performance. So I am not someone who's going to get into statistics for a fundamentals course, but yes, you would be expected to, know what are the methods to calculate how accurately your model is working. Finally, you can deploy the model as an endpoint and test it using sample data in a JSON format. So you could send data like this is the image that you want to test, or this is the input that you want, and then the model could take the input, give you an output. Something which we'll see today. So I won't go too deep into that. The second is classification. So the first one we looked at was regression. So the questions will ask you if this is regression, if this is classification, or if this is clustering. So you'll have to divide in one of the three. So that's how they ask questions. So we've already discussed that wherever we read regression, it has something to do with stats, it has something to do with numbers, it has something to do with predicting what numbers would go. So if the price will go high or low, what model will you use to predict if the housing market is going to get expensive or not? I would say the answer to that is going to be regression. A regression model will be best suited for that use case. For classification, it is a form of supervised machine learning. Again, this is supervised, that is used to predict which category or class an item belongs to. So we are going to do a practical on classification today that will make things, slightly more clear for all of us. But yes, in simple terms, what we talk about when we see classification is categorizing. So if you see something and you want to put it either this or this, for example, if you look at an image, you want to classify it either it's an elephant or a giraffe or a lion, that is an example of classification. So this is what you need to know. So if they ask you a question in the certification exam, what will be classified? We need to create a model that can classify if an animal is a giraffe or the animal is a lion. So wherever you see or, you have, this or this, this or this or this, wherever you have to classify something, wherever you have to judge something and, you have to decide that this belongs to this category, that is classification machine learning. So let me say this once again, wherever you see numbers, you are going to put that in regression. So the answer to that question is going to be regression. Wherever you see you have to classify something, you are going to put that in the classification machine learning category. Uh, Now, this can be applied to binary and multi-class scenarios and is commonly used in industries such as healthcare, finance, and marketing. Now, one question that I answered, I remember this because when I gave my exam, I think it's been more than 1.5 years or something, but when I gave it, and then obviously many of my students have given it, and they did discuss how, what kind of questions were being asked. So considering that, for classification, the question that I got was, we have a machine learning based model that predicts if a person has a X and Y disease or not. I just don't want to name the disease, but yeah. So the question was like, uh, we have a machine learning model that is predicting if a person has a disease or if they don't have a disease. So when they're asking you to put the person in this category or this category, that is classification, because your machine learning is going to look at the data set, it is going to look at how it was trained, and then it will be making an informed decision that, okay, from my understanding, I feel that this might be a case of this disease, or I feel this might be just a totally healthy case. So wherever you are putting it in either of the boxes, options could be 2, 3, 4, 5, as many. But if you have to decide that where will this thing fit in, and you have that, decision making going on, you are looking at classification. Does this make sense to all of you? Give me a thumbs up. A lot of questions will be asked on this topic, so I want, my audience to be interactive. Anyways, it's the practical day. It is a Sunday morning, a cold one here in Montreal. So I do not expect everyone to be at the top of their, energy levels, but then I want you to be energetic enough to respond, just so that I'm sure that people are listening, people are aware, and it gives me a kind of feedback. Okay. Going forward, classification scenarios include predicting patient health outcomes, analyzing tech sentiment, and predicting the success of a business venture. So okay, sure, Gautam, I can do that. So basically, for the certification standpoint of view, they will be asking you, is this scenario either regression? Is it classification? Is it, they might give you a couple more scenarios and then you have to choose from the ones. So the first one we talked about, wherever you have a scenario like uh, how many burgers will be sold today at X and Y restaurant? If someone has created a model for that, what category of machine learning is that model using? So that wherever you have numbers, you're looking at regression model. The second is classification. So if someone has created a model that will categorize if someone is a good driver or a bad driver, or if someone has created a model that will classify if someone has a disease or if someone does not have a disease. So wherever you have this or this or this or this, wherever you are putting an object within a class category, so wherever you're classifying, you are looking at classification. Does that make sense, Gautam? Okay, awesome. So when you go for the exam, please make a star on these slides. Do not forget to read them. Regression machine learning, look at what the use cases are. Classification machine learning, please read what the use cases are, because this is what is the exam question. So people tend to get confused thinking that, I'd never heard about a model that could predict COVID. But yeah, there can be a model that predict COVID because they're classifying it. That's why it is a part of classification. Now, the steps for classification, you prepare the data, you train the model, you evaluate the performance, and you deploy a predictive service. Exactly the same, or I'll say, the steps will be pretty much the same. Again, you do not need to know these steps in detail for the certifications, or, not something that I'll go in super detail. We can look at it later if we have some time. The next category for which they'll be asking you questions will be clustering. And let me say, I think about 10 to 15% of the questions will be on this topic. So if you listen to this topic, it's hardly going to take you about 5 minutes to revise it and understand it. And when you put this live in the exam, you've already cleared 15% of the exam. You need 750 marks out of 1000 to pass the certification. So this makes a significant difference. So just read through this. These questions usually no one misses on them. So if you've read them once, you'll easily get a score on this. Moving on, clustering is a form of unsupervised machine learning used to group similar items based on their features. It is commonly used in various industries such as marketing, rideshare applications, and customer services to cluster customer attribute data, geographic coordinates, and written feedback, respectively. Clustering does not require previously known cluster values. So clustering is basically grouping similar data. So please understand this. The difference when we start with regression, we are looking at numbers. Then we go to classification, we are classifying that this is this or this is this. And when you have data, you want similar data to be together. That's where you're using clustering. Now, this slide was designed keeping in mind that, the exam questions. So the cases that have been explained over here are the cases that they'll, ask you in an exam. So if you see, they give an example of a ride share where machine learning needs to predict if two people will be going to the same destination. If so, at what time? Or if we get time into play, then it's again a number, so it might be confusing. Uh, a model might use more than one machine learning techniques at once at multiple stages. But let's say if we are simply doing an analysis of two people will be traveling together or five people will be traveling together. So we need to study the patterns of these five people and try to find similarities. Let's say if I'm just going to pick the names from the right this time. So I see here. So let's say here wants to here has a history of traveling from Montreal to Ottawa every Sunday. and then let's say Amandeep travels from Montreal to Ottawa every second Sunday, and then let's say Arsh travels from Montreal to Ottawa every second alternative day. So we could have a model that will predict that, okay, from the data that I have about these three people, I think on Thursday all three of them will be going, so we should have a cab available for them. And then you could send out a message to your drivers that, hey, we are predicting that a demand might come in, so if you're available, be available on that date so that you could take advantage of the customers. I know it's a very broad example, but these are the kind of examples that you would have to put in clustering. So just remember, when you look at the word cluster, it means putting similar data together, people with similar interests, people going to a same place, you know like the coordinates, anything to do with geography, where you want, if it's going to rain in this specific place or not. It's raining in Montreal, will it rain in Ottawa? Things like that are a part of clustering. The steps are pretty much the same at a broad level. You prepare the data, you train the model, you evaluate the performance, and you deploy a predictive service. The evaluation is obviously different for all of them, because these are three different types of models. But other than that, the basic four steps remain the same. Now, I'm not going in a lot of detail for this because I want to have some time for the practical. And once we start the practical, it takes, there is some waiting time for your, model to get trained. And that's when we can come back to these slides. So now coming to computer vision, we're just one slide away from a practical, one or two slides. No, three slides away from a practical. So we've already discussed this yesterday, but to put this in a definition perspective, computer vision is a field of AI that involves teaching machines to process images and understand visual data. This can be used to identify and organize objects in photos, extract text from documents, and analyze movements in each space. So again, when you give your computer the capability to look at images and videos and make decision on what is the content, what is the character, if a person is there, who is the person that is there, and if it's some other thing. For example, I was giving an example of a phone. So if it sees a phone, it will be able to recognize that, okay, this is a phone. If it sees maybe, let's say, a car, it should be able to recognize it as a car. And since the practical is totally upon this, so you'll get to know more as we look at it just in a bit. Now comes the topic for Azure image analysis. So Microsoft's computer vision service provides pre-built computer vision capabilities to analyze images. We did this yesterday where we put in an image and we got the analysis that, this is what is there in the image. We can use it to detect objects like, what is there in the image. For example, a building, for example, a river, for example, a car, a pedestrian, a human. We can tag features, we can detect faces, we can categorize images. To use the service, users must create a resource in their Azure subscription, specifically from computer vision or as a part of cognitive service resource. I'm going to talk about cognitive service more when we start the practical, but yes, this is something which we did yesterday. So I created a cognitive service, which is basically nothing but an API to the resources, where we had a computer vision resource. We could send data, we could do the analysis. Please remember one thing. In Azure image analysis, we did not train the model. We just used the model. So if there was a pre-trained model, that model knew what a building looks like. It knew what the car looks like. It had a lot of information, right? So we did not put in a lot of effort to train it. We put zero effort in training it. All we did was we consumed it by sending our data. Does this make sense to all of you? Give me a thumbs up, because it's very important for us to understand what we did yesterday and what we'll do today. So yesterday, when we used the Azure image analysis, our job of training the model was zero. We just sent in the data, it analyzed it for us. It was a pre-trained model. Does everyone understand this? Give me a thumbs up. Okay. Today, when we go into custom vision, we will be training our very own model. So we have a very important role in how the model is going to work. So we will teach it that, hey, this is a cycle, this is a pedestrian. Please understand the difference between the two. Other than that, we'll also teach it, hey, this is what a giraffe looks like. This is what an elephant looks like. This is what a lion looks like. If I show it a picture, tell me what is it? Is it a giraffe? Is it a lion? Is it an elephant? If we train it for these three things, we have to send one of the three to, for it to come with the prediction that, yes, I feel I'm 90% confident that this is what is there in the image. You cannot send a human's picture and ask it if a human is, a lion, if a human is a giraffe, or if a human is, let's say, a zebra. Obviously you're not going to get the desired result. So that is obviously, something which we have to control when we do the practical. And that's why I've given you the images folder. So we'll train it from a specific data so that it can understand what we are actually trying to give it as an input. This service can provide description, tags, borders, coordinates, brand, celebrity detection, and domain-specific content recognition. Now, we just looked at the basic use case where we were looking at the service from a very broad view, but it has very specific uses as well. For example, you might have seen people try to defame people by using their pictures, using their photos, and then you might have seen, it's a very common thing. Many YouTubers have discussed this in the past, saying that their content has been, taken down from YouTube. So obviously there's no one who's watching the content at all times. There are automatic, you know, analysis tools that go through the video and try to find out what are the contents of the video. So if they feel a brand is being used, a celebrity is being used, and I'm not talking about YouTube in general, but let's say if you have a use case where you have a policy that, if someone's uploading a video, they should not be pirating it. So the probability of piracy gets higher if they're using a celebrity's face to say something. So if that is being used, you can run this API. It can tell you if there is a celebrity in the image or not. It can tell you if a brand is there in the image or not. So if a brand should not be there and people are using it to, monetize and get, uh, unfairly use it in their advantage, this service is used by brands and celebrities as well. So what they do is they go through the content just to be sure that no one is using their pictures, no one is using their brand if they are not supposed to. So this is one thing that could be used. Uh, just the last slide before the practical, that is Azure image classification. So Azure custom vision services allows users to create. Now, again, we're talking about custom vision. We did discuss this yesterday, that custom vision is a service by Azure that we use where we given our own data set. Now, what's the difference? What makes it different from the studio? In studio, you need to have some own code, right? It makes it easier for you to write code, but at the end of the day, you need to have some programmatic experience to be able to solve some problems by writing some code. But here you have zero code requirement. All you have to do is you have to give your image. You have to tell Azure, phone, 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 this angle, this angle, this angle, all the angles, front, back, everything. And then when you ask it, you show it this, what is this? It tells you, oh, this looks like a phone. So that's what we'll be doing today. So in custom vision, we as the consumers will be training our model without the need of writing code. So Azure Custom Vision Service allows users to create image classification solutions by training model using existing images and publishing them for predictions. Users can use custom vision or cognitive service resource for training and prediction. Model training requires sufficient labeled images and evaluating performance using precision, recall, and average precision metrics. After training, the users can publish this model and use the project ID, model name, prediction endpoint, and prediction key for predictions. The steps, how this works is we will go on to Azure. We will go to a website, a UI, where we will upload our images. And then we'll tag it that, hey, this is what an elephant looks like. This is what a lion looks like. This is what a giraffe looks like. Not one image, but maybe 10, 15 images each. And then what we'll tell it, hey, this is not what an elephant looks like. This is not what a giraffe looks like. This is not what a lion looks like. So we'll send it positive. We'll also send it negative. Once we send it all the data, and we start the training. It takes anywhere about 10 to 15 minutes to train. Once the training is complete, we'll pass it a picture. Hey, this is a phone. What do you think this is? And then it will be doing the classification. Obviously, trying to classify a phone in one of the animal categories is not something Azure can stop you against, but that is something which is stupid because it will not yield you any result. And that's why when we do the analysis, we are trying to train it for animals. So we want to give it an image of an animal to detect. If we want to train it for cars, you could maybe do this on your own time because I do not have enough images because there are again policy rules and regulations and stuff that comes into play. So the images that I'm sharing with you are from official Azure documentation so that there are no copyright issues around that. You could be using your own images for training your model, and you could work around with it if you have to. Once your model is trained and you feel it is accurate, if you feel something is wrong, you'll have to correct it with time. But once you feel that your model is at a good spot, you've got everything that you need, that is when you can put it into deployment, and you could be using it like an API using the cognitive service. Okay, so without spending a lot of time, let's start with let's start exploring the image classification. I'm just going to stop sharing my screen and I'm going to start sharing my web browser real quick. Give me a moment. I would need a couple of resources. Now, a quick disclaimer, if you guys have downloaded all the zip files, amazing. If you have not downloaded the zip files and you do not want to do the practical, please follow me. If you do not know where to find the zip files, they were sent in the attachment, as an invite that was sent to all of you in the morning. So just give me a minute. Okay, I think I can now share my screen. So I hope everyone can see my screen. Uh, I have opened the customvision.ai. This is the website from where we'll be accessing it. This is a part of Azure. The URL is just a little different. I'm quite sure many of you would be doing the practical along with me. So for that reason, I'm sharing the link in the chat. The link is customvision.ai. And I'm going to be a little slow so that everyone can catch. Okay. For those of you who are watching this on YouTube, you could maybe, fast forward this, or you could skip it, or you could watch this in 2x. It would be helpful for all of you. Okay. So once you come into customvision.ai, please sign in from the very same Concordia credentials, because this needs to be tied up to your Azure account. And please use the same credentials as you did for creating the account last time. And this is what you would be seeing. So I am inside my Concordia account. That's live.concordia.ca. If someone's not from Concordia, you might have a free Azure account. Use that. Uh, and this is for the people who are watching this on YouTube. But since this is ECSGS workshop, I hope everyone's from Concordia. And I'm an alumni and I still have the access. It's been about more than a year now. So I assume everyone, who is watching this and is an alumni, you still have access to your free Azure account. Okay, hit OK on this, and this is what you'll be able to see. So this is where we are going to start training our model. And to start, by the way, everyone who's doing the practical, I hope you're on this page. Anyone who's not on this page, quickly raise your hand. And just as a disclaimer, if you share your screen for asking a doubt, please be sure no private content is displayed because the video goes as is without any blur on YouTube. So just be sure if you're doing that, uh, you do not have anything that you do not want to be uploaded. So I hope everyone has this page. If you have it, give me a quick thumbs up. Just want to be sure everyone's following along. Okay, great. What about the others? Not doing the practical? Okay, no problem. So if you have this page, please click on new project, because we have to start a new project. But before we can do it, we need to create a new resource. So this is where you're going to encounter the first thing that you need to do. This is how you create a project, but you cannot do it till you have a resource in Azure. And as I said this before, this is Azure. It's just a different URL for using the custom vision, service. But this is technically using Azure. So the first thing you have to do after clicking on new project is you need to create a new resource. So there's an option of create new. Click on create new. And let's start by giving this a name. So the name to this resource could be custom vision. And I want it to be a little different so that I can go and delete the group once I'm not using it. So let me call it custom vision. Uh, sorry, PCSGA workshop. Now, in subscription, if you remember, when we created an account during AZ-900, we were using an Azure for Student subscription, which is a free subscription. So it gives us certain credits and we would be utilizing them. So please select Azure for Students. If you do not have a free account, please do not do it because as this might be expensive. So if you have a free account, you could follow along. If you do not have a free account, it's your choice. But please make sure that you're selecting Azure for Students because this subscription does not have your card attached. This is the free subscription that all of us get. Does this make sense to all of you? Give me a thumbs up. I might want you to be interactive a bit for the practical because I don't want to repeat the entire thing 5 times. So I'm sorry if this is going to be redundant, but if you're doing the practical, please keep your thumb on the thumbs up. You might need it quite a few times. Okay, you might have IITS WVD that I am not sure why people are getting that. It has something to do with how they have configured your accounts. And definitely, I do not think it's going to be free. So please do that at your own risk. Everyone can see Azure for Students at least, right? If you can see Azure for Students, please select Azure for Students. If you can't see Azure for Students, that is when things get tricky because I do not want you to be using a Concordia subscription and you do not want Concordia to be built for that because you never know if you build them, they might ask you to pay that back. So please be sure you're using the Azure for Students subscription because this is the free subscription that we get. We did not create this. We just got it by enrolling from our student ID. So this is what it is. Next is you have to use a resource group. We could maybe go and create a new one so that it's easier for us to delete and manage. If you cannot see Azure for Students by any reason, I would recommend that that is some discussion which we could take in the break at 12. So do not do it just now because obviously you do not want your university to be paying for your practical. In that case, I am not sure what the policies and rules are, so I cannot comment on their behalf. But if you have a student, please continue. If you do not have a student subscription, please wait. This is something which we could discuss in the break. This is something which you could discuss with your university. Try to get that figured out if it does not work in the break. And once that is sorted, you could look at the YouTube video and do this practical. But please continue only if you have an Azure for Students. I do not want anyone getting billed because then I would not be responsible for that. Okay. So resource group, if you've worked on this before, you might see quite a few resources added in the resource group. But because yesterday I was playing around, so these resources were created with time. So, but for you, it might or might not be the case depending upon if you used your Azure account before. So let me just create a new resource group. Let's call this, I'm just going to call it custom vision practical group. And I'll place this in maybe, let's say I have quite a few options. And as I said before, not all services are available in all regions. So, I do not see Canada over here. So I have North Central US, UK South, Central India, Australia East, Japan East, Southeast Asia, West Europe, North Europe. And so, you see it's mostly in Europe, Asia, and US. I cannot see anything in Canada. So the region that is closest to me is the region that people preferably select. And for me, I will select East US, which is one of the closest regions to Montreal. It is somewhere close to, north of New York, northeast of New York. So I think this should work good for us. I'm not sure, Gautam. I'll have to check. It can be Boston, but I do not want to comment on something which I'm not sure about. So you can go, you could select that. So I've selected custom vision practical group, and I've selected the location to be for this group to be east, and that's where I'm going to put the location for my resource as well. So I want my resource to be there in East US. That's something I'm going to select. The kind is going to be cognitive service. So cognitive service is basically when you know, when you use an API to interact once you publish it. So I'm going to select the kind as a cognitive service, and the pricing tier is going to be S0. That technically means free. It's free for students. So if you have Azure for students, you'll have S0. If you guys see this before clicking create resource, give me a thumbs up. Just want to be sure everyone is following along. For those of you on the video as well who will be watching this later, so you can give it any name, select this subscription Azure for students. Any other subscription might be paid. Resource group should be custom vision practical group, which we just created. You could create another one if you want to. The kind is cognitive service. The location is East US, closest to the endpoint of my users. The pricing tier is S0, which technically means that this is free. So I hope this is good for all of you. Click on create a resource. The prompt might just go away within a few seconds, but it takes up to 10 minutes to create the resource. Now that is the bad thing about this UI. So I could technically close it and I could start creating project, and my projects will never get created because this is now going into your Azure account to create the resource. So it does take some time. Now, if you've seen my previous practicals, whenever we create a resource, it ends up taking some time for sure. So let's just wait for it 10 minutes. Okay, I think Bowen with you, it's something new. So I'm just going to come to you in a bit. If things go fine, your resource will be created in a bit. And that's why I've already clicked on create project. I'm not going to close it. I'll wait for it to create and we'll continue once it has been created. How many of you did not get an error message? Give me a thumbs up. How many of you are done creating the resource? How many of you see something similar to my screen where this has been, it's non-clickable. That means it is creating something in the background. Okay. Okay. So that is quite a few. Now, for those who got an error, let me. Okay, awesome. Yes. So that is the solution. If it did not work for you in the first go, just click on the create project once again, and it will do it for you. So I'm not sure. Maybe some bug with the UI that they have, but so because it does not do it in the first place. But yeah, it doesn't. It does it on the second or third try. So I think we are good. So now, how many of us are on this page? Give me a thumbs up. Quite a few. That's nice. Okay. So if you have the same screen like me, we have nothing to do for the next 10 minutes. I'll tell you why. Because technically, we could don't do it. Just look at my screen. I'll tell you what's going to happen. You could just close this and then click on new project. But you cannot do anything because you do not have the full prompt. So when you want to click on create a new project, you should be able to see 6, 7, 8 fields to fill up. In the meanwhile, I'll take you to portal.azure.com. You can just observe my screen. It's more or less the same thing. We'll wait for the resource to get completed. So let me see what are the resources that I have. Let me go into my resource groups. So Azure Workshop Demo Machine Group. No, Cloud Shell, Custom Vision Practical Group. Yes, this is the one that I created, right? Custom Vision Practical Group. So if I go into this, I can see there is a cognitive service multi-service account that is custom vision ECSGA workshop that I just created. if I go into this, a lot of stuff could be done. I could be using the decision service. I could be using language, speech, vision, metrics advisor, form recognizer. But I'm only interested in custom vision, so I'll wait for it to complete. And once this has been completed, I should be able to see it here. Not done yet. So let's just wait. We have to be a little patient with this. So it's doing a lot of stuff in the background, and that's why it's taking some time. In the meanwhile, let me show you the subscription that I'm using. That is Azure for Students. And my role, I'm the owner of this plan. So these are my limits that I have. This is the costing that I've incurred till now. Let's see how much money I have in this account, or the budget that I have in this account. Let me see. So the activity log, let's go to the budgets. I don't think I did set up a budget here. So, okay. So I got this from Concordia University because this is the AD I'm using. Again, that's not a part of the content, so I'm not going to go in details. This is the spending rate and forecast. Not sure where can I see my credits. I might have to go to the education portal to see that maybe. So just getting the student offer details for me. Yeah, so this is where it is. I got 100 US dollars, approximately equivalent to 136 Canadian. So the available credits that I have is 136, and the days till they expire are 352. So I got 365 in the beginning. It's been about a few weeks since I've created it. So the days are going down. Okay. It shows project types, classification types, and other fields, right? Project types, class. Allocate, in what context are you talking about? Okay, yeah, this, right? So yeah, it has been created. I'm just going to come to this in a while. So I was just showing people around what the education portal looks like. So this is where I have 352 days to consume my $136. And I was playing with the resource sometime back, I think, and on the first session practical, I did use it for about an hour or something, and then it did cost me $0.02, like 2 cents approximately. So that is kind of fine. Everything is under control. Everything is under the free tier. On top of the $136 that we get in Azure, we also get a lot of free services. Click on it and you'll be able to see what is the limit that you have used for each and every service. Okay. So this is what it is. I'm not going to go into the details for now because we are almost ready to go with the practical. So I hope everyone is on this screen. Let's continue from where we left. Our resource would have been created by now. And now when we click on new project, we see this. Is everyone able to see this? The project type, classification type, and domain. Give me a thumbs up if you can see it. Because previously, if you clicked on it, you would not have been able to see it. Only name, description, and resource was available. But if you click on new project and you can see project type, classification type, and domain, give me a thumbs up. I want to be sure how many of you are doing it with me so that I can get an idea about how much time I have to spend on this. Okay. How many of you do not have this? How many of you are doing the practical and do not have this? Please let me know. Okay. So I guess everyone has it. Everyone doing the practical has this. So let's give it a name. The first practical that we are doing for the day is image classification. And to be specific, we are classifying animals. So create new project. Let's give it a name. So let me call this classify animals. Okay, you can give it any other name if you want to, but since this is going to be on animal classification, I'm calling this classify animals without a space. That's how I want it. You could use any other name that you have to. Let me give a quick description. This is a Okay. So this is a model for classifying giraffe, elephant, and lion. Elephants, giraffes, elephants, and lions. Whatever I want to add over there, it hardly matters. Now, the resource, because we just created one, so we were waiting for this to get created fully, is Custom Vision ECSGA Workshop. If you created another resource by another name, you could go and use that. But this is the one that I'm going to use. The project type is classification, because this is what we are going to do. We'll be classifying. So we'll be putting them in one of the categories. And again, this practical is going to be helpful when you see exam questions, you'll be able to relate to this practical a lot. So classification, and we are going to do single tag per image. So this is basically you are deciding on if an image is going to have multiple tags or if an image has a single tag. Since we now this is a basic practical that we are doing, what we are going to do is we'll show it an image with one animal in it and we'll ask it what animal is there in the image. So we'll be selecting multi-class single tag per image. If you want to do another version of this, by all means you could do it later by looking at the video. But for now, I think I'm just going to stick to the basic. And then you have a domain where you want to put this. So what scenario are we using this for? So are we using a general one? Are we using it for food, landmarks, retail? And then they have, the compact ones as well. So we'll just go with the default domain that we have, general A2, and we'll click on create a project. So once we click on create the project, this is what we would be seeing. If you see this, give me a quick thumbs up, all of you. Okay. So now is the time where we upload a couple of images. So please listen to me very carefully. I think I'll have to share my entire screen, not just one page for this duration. So okay. I hope now you could see my entire screen. In the email in the morning, you've got two folders, road safety and animals. Road safety is a later practical that we'll work on. For now, I'm interested in the animals.zip. So all of you, please extract the animals.zip in your machine. I've extracted this in mine. Please extract the animals.zip and you'll see, three subfolders within this where you have an image for, you have a folder for lion, you have a folder for giraffe, you have a folder for the elephant. Yes, we selected general A2, the default. Is everyone able to locate the lion, giraffe, and the elephant folder? And the classification type is multi-class single tag. Gautam, you found it? Okay, awesome. So yes, so I hope everyone is able to locate the lion folder, the giraffe folder, and the elephant folder. So let me start with lion. You can see I have quite a few pictures of lion at different angles, multiple lions in a picture, in multiple backgrounds, black and white, colors, different context, different backgrounds, different shading, so that if someone gives a black and white picture of the lion, we could still be able to predict it. So obviously, this goes without saying, the better images you have and the more images you have, the better your model is going to be. But in the best interest, just to keep it short and sweet and to use the data that is officially available on the Azure documentation, I'm not using anything of my own. So for that very reason, you can see that these images, some of them are 49 KB, 12 KB, 500 KB, 23 KB, and all that stuff. The better the resolution, the better the image, the better the clarity, the more the number of images, the better this model gets. Just remember, this is a demo. This is not a real world model. And that's why I'm having like about 15, 20 images each. But in a real world scenario, 17 images each. But in a real world scenario, you might want to have 100, 200, 300, or even thousands of images so that the model matures over time, something that we talked about yesterday. So please click on add images. Don't add all of them together. What you have to do is you have to go to the location for the lion. Let's do it step by step. First, go to the folder for lion. It will be in your downloads, animals lion. So the folder that I gave you, wherever you downloaded that, if you have extracted it correctly, you'll be able to see lion, giraffe, and elephant. I'm interested in the lion first. So just go to the lion and you'll see all these images. Is everyone able to open this on their machines? Give me a thumbs up, because that's the only way I know everyone's doing it along with me. Okay. Control A, because we want to select all of them together. If you're a Mac user, Command A and hit open. So you're going to get these 17 images only of the lion, because we have to tag them. If you get all the images together, please close it, do it again, because we want similar images. We do not want to tag a giraffe like a lion. We do not want to tag, another animal like a lion. So we only want the lion images. And here we can give a tag called lion. So we are training it. We are telling it, hey, custom vision, these are all the images we have, and this is a lion. And then you hit upload. Now this does take, because these are low resolution, these are not super high resolution, it did not take a lot of time. So now our model knows that it's not been trained yet, but we have uploaded the data. So the first step was getting the data right. So we've given the data for line, but this is not enough. Just a sec, someone at my door. I need to give them the permission to enter the building. Okay, there we go. So we have added the pictures for the lion. Let's go next. Do we name my tag as lion? Yes, you will name the tag as lion. Okay, once you're done with that, let's click on add images. Let's go back to the animals and let's do it for giraffe, I say. So we could take in all the images, Control A, open, and now we can see multiple images of the giraffe. Within my tag, you're going to tell this that, hey, this is what a giraffe looks like. Hit upload. So now you've got 17 images of your giraffe, you've got 17 images of your lion. Similarly, do the same thing for the third animal, that is elephant. Control A, open, and then you enter elephant. Straightforward stuff. Yes. Mohammed, are you trying to say something? Okay, you are on unmute, but I could not hear what you said. Okay, just muting you because could not understand what you were saying. Yeah, please type your question in the chat and I'll be answering you. Okay. Coming back, so you see now we have 17 images each, 17 for elephant, 17 for giraffe, 17 for lion. We can test them by selecting only elephant. So we see 17 pictures of an elephant. If I select giraffe, I see 17 pictures of a giraffe. Now 15 is the minimum requirement. But because I got them from the official doc, I could find 17, I got all 17. You could have 100, 200, 300. The more, the better. And then lion, you see 17 images of the lion. Please give me a thumbs up if you have uploaded all three of them and you have verified that you have given the right tag. Give me a thumbs up, please. All of you doing the practical, I want you to be a little active, please. Okay, for those of you who have not done this or having any issues, now you can raise your hand and then you can unmute and ask me questions. Do not train your model just yet. It's not going to train immediately because it's going to pop up an error and I'll be talking more about the error in a bit. So everyone who's is at this page already? If not, please type in the chat, raise your hand, unmute yourself, whatever you want. Okay, so now let me hit train and it's going to fail. You guys do not need to do it. You can see from my mistake. Obviously, I'll be doing the quick training. I do not have time for the advanced because it takes a lot of time. So I'll just go with quick, which says it takes minimum budget 1 hour. that is basically what it is going to cost me to the account. So if it runs for 10-15 minutes, it's still going to cost us for 1 hour. That's what it is telling us. The moment I hit train, it's going to come back with an error with saying that, you do not have anything negative. Let's see if it does that for us. So it is in training. We let it train, but then obviously it's not going to be as per how we want it to be. Because when I tried this before, like sometime before, it used to give a lot of errors, but now it's not about the error. It's not shown me one till now, but it's more of like about the best practice. Uh, so you guys do not have to train, so you can calm down for that. Just give me a moment. Okay. So there's another category that we should be adding within this. I don't know why it's not giving me the error for now. Even if we don't have the error, what happens is we've given it everything positive, right? We have shown it what an elephant looks like, what a giraffe looks like, what a lion looks like. We do need to tell it what is not an animal, so that it has something negative as well, so that it can give you better results. If I do not do that, the threshold with which the return the prediction will come in is going to be lower. So if you want that to be higher, you'll have to go and you'll have to create a new tag. So there's an option to create a new tag. Please click on this plus icon and select not animal, because you see all these images are with sceneries. So please understand this. The images are with sceneries. Hit is negative. Click on save. Now I'm telling you why we are doing this. So we have selected not animal. We have saved it. We've added that as a tag, and it is a negative tag. The reason we are doing it because all these images are with sceneries. We do not want the model to be trained that it starts detecting the sceneries instead of the animals, right? So we need to upload certain images where we have only the scenery and no animal at all. Does that make sense to all of you? So we need to upload the sceneries so that the model can understand things better. And here it is not animal, and that's why it's a negative that we are trying to pass in, not a positive. By default, all of them were positive. So please go click a new tag. You have to make a negative tag. There'll be an option of is negative. Click on that and give it a name. There's only one negative tag for the entire model. That's why, since I've already created it, I'm not seeing the same option. But I hope all of you, when you click over here, call it not animal, and then there'll be a tick for negative. So when you see this on the left, you'll see this, so this symbol, which looks like no entry, and it says not animal. If you see this, give me a thumbs up. I just want to tally the number of people who are doing the practical, if everyone's able to catch it. If not, I would repeat it again. Everyone is done creating the tag not animal, which has the symbol in the beginning. Okay. So now obviously we need to add some data that is not animal, right? So click on this and we need to add images, which are just sceneries. Uh, Now you could be using your own images, or if not, let me share certain images with you. I did not send them in the email in the morning because otherwise the email would have definitely gone into junk for all of you. The size was exceeding. So I'm just going to download 5 images from Unsplash, which I've already kept the URL with me, so won't take some time. Let's come back to sharing my screen. So yeah, so I have these 5 images that I'm going to share with all of you. First, let me add them over here. Okay, this looks messy. It's not giving me a drag and drop. So there we go. These are the 5 images that I have. And these are the sceneries. So these are without animals. Obviously, I could have gotten something better if I would have searched for a green forest or something, but I think it does the job for now. Okay, just a sec. Add images. Open them. I will select not animal and I'm going to click on upload. Now I know you do not have these images, so I'm going to upload these images for all of you in the chat. Just give me a minute. Okay, so I think there is some restriction over here on what I can share in terms of the file. It's only allowing me to share from OneDrive, Google Drive, or SharePoint. So what I'll say is you could have your own images, or just give me a minute before I can share them with you. Just a quick minute. Okay, just give me a tiny minute one more time because I was trying to figure out how I could be sharing the resources with you. Okay, I hope my screen is not shared. Yeah, so I'll just put them on my personal OneDrive and I'll share it with all of you. Okay. So let me just quickly put this not animals for you. Okay. Less than a minute and we'll have it. It's almost done uploading. Okay, share this. Anyone can view. Okay, so let me come back to sharing my screen. Now I'm sharing a link in the chat. For your attendance, we'll be sharing that after the break. So there you go. Now you could let me see what's there in the chat. How can you train? Can you show the step? I'm just going to show you how to train in a while. I've given you a link to one of the folders. You can download the folder from there, that link, which has these images, or you could be using your own images. Look, if you have sent a link, this source is okay to use for downloading scenery images. Uh, Honestly, you could be using anything. Just be sure that the rights are, right or not. These images kind of look fine, but I'm not sure about the source. So just see if there are any usage rights around it. So the ones that I've shared are, you could be using them for this purpose. So please use the folder that I've shared with you, or use your own images. I hope everyone is ready by now. So you have images for elephants, giraffe, lion, and then you have a not tag, not animal, where you've just uploaded these images. Now, these images are high resolution. Obviously, that is going to make the process a little slow, but that's how it is. So once you're done with this, on the top right side, you see the option of train, the green button. That's what you have to click along with quick training. So when you do that, it is going to take some time. So the first one was done. You can see the first one had lion, giraffe, and elephant, but it did not have, the not category where we just uploaded the scenery. So technically, I could test it. Yes, all of you should train. If you're done uploading all the images, if you're done uploading the not category as well, please train. As I said, not category is something which used to be important previously. Now it's not giving an error for that. But if you do not add the not category, the results are not going to be the same. So it makes more sense to please do that. And I can show this to you now. So if I go into performance, I can see this was my first iteration where I just started lion, giraffe, and elephant. In the second one, it is training. It will take about, a few minutes. And when you click on train, automatically it's going to train with all the data. So if anything is selected or nothing is selected or one is selected, it is training for all the data. So when you, in this process, what is happening is it has got images of lions, it has got images of elephants, it has got images of a giraffe, and it has got images that are not an animal, that are just the scenery. Now, these sceneries are, in the white background. If they were in a green background or a yellow background, it would have been better. But since this is a test, it hardly matters. You are going to get, very accurate results once this is trained. You can go into performance. You can see, what's the status. So I trained one 11 minutes ago. It got trained, but it did not have that. So I'm just waiting for the new version to get trained. And once it does, that's when I'll be passing some data. Okay. So you can see the precision recall AP. Obviously, these values, are not super accurate. And then, there's an option to publish them, to make an API out of them. But that is something which is not required. So I'm not going into that. We can just go back. We can wait for the training to finish. And so once it is done, we can start with the quick test. So is everyone done with starting the training at least? Give me a thumbs up. Is everyone done locating the folder, uploading all the 17, 17, 17 images each, and then some scenery images, either your own scenery or the scenery that I shared with you, whatever works for you. If you select one or if you select none, it doesn't really matter. Just click on train. And once you start training, it will train for all the data that it has. So I think that should answer your question, Preetham. Now let's wait while I find a URL to the giraffe resource. So now what I'm going to do is I'm going to find a resource online, which I'm going to test, what that is. So for example, let me go to, so let's see, Wikimedia maybe. And this is a totally new image that I've not tested against. So I'll be testing one for, a few images random and one from the URL that Azure shares with us for testing. It's taking some time for the model to train. Until then, let me run a quick test using my old model that was already trained without the correct file. So if I pass in this image, it has come up with a prediction of lion 99.9%, and that is very high. So you see your model has been trained. I did not give in this picture. I just got a random picture from the internet, and now it is able to recognize what a lion looks like. Let me see if I can find another image. So I'm just using Wikimedia because I can get direct links to images using this. Let me use this. This is slightly more complicated. I'll be surprised if it is able to, locate this, because a lot of stuff in the background as well. So it's doing the analysis. It's definitely going to take some time. And this is the new model now, by the way, because my new model has been trained. I hope your models would have been trained by now. So you can just click on quick test, and then you can have a URL, and then you could test against it. So I'll be sharing the URL in a bit. Just give me a minute. I'm trying to analyze this. This is a very high resolution image. That's why it's taking some time. Till then, let me find something low resolution for everyone to test. And since I'm not downloading them, I'm not doing anything which is not supposed to be done. Not accepting it for some reason. I don't know why. Maybe it's too big. That's why. It looks to be of slightly lower resolution. The image is too large. Okay. Let me pass in the. Okay, so this is an image from the testing itself, and we run through it. Obviously, there's some background to it. It is able to predict that the image that we have is a giraffe. By now, your models would have been trained. So I'm sending a URL to all of you to test. Let me find a couple more URLs. And obviously there are size restrictions and stuff, which I'm not talking about in detail for now. So you have to do some pre-processing, obviously, because these are all very high resolution images. You could scale down to run it against this test. Again, the same issue. Not sure if I can search for something low resolution. Yeah, maybe this should work. Yep. So this seems to be small. There it is, 99.8%. It is a lion. So you can just use any image from the internet. Yes, I did filter it by image size. So that's how I could find it. So just upload an image and you would be able to see that it is able to do the prediction. Now, once you're confident that, yeah, this is working kind of fine, you can see what it has done. This is what it is. This is what it is. You can tell it that if this was correct, if this was correct, this was wrong, whatever you want to do with it. Once you are done with it, you could publish this model. We are not going to publish it. Anyways, whatever we are doing here is again not required for the certification, but this could be a good minor project. This could be a good starting point in terms of AI for many of you who are just starting to work with AI. Okay, so that's why we are doing this, and it does not require a lot of technical skills. At the same time, it is something which is fun to do, and it is something that could definitely easily be added to your projects as well. Uh, okay, let me look for this thing, because here the background is of a white shade. So let's see how well it performs. Just trying to run it against different data. You could be using your own data. I'll just share this URL in the chat for the files that I'm testing it against. And there you see 99.4% probability it's a lion, which is kind of good. Let's see what happens with the first one. That is 99.8%. Now, these results again depend upon the more data you feed in into it, the better it starts getting. And that is what it is in general. So I hope this makes sense to all of you. If you're able to do this practical, give me a thumbs up so that we could now move to the second practical. Okay. That's awesome. So I hope for those of you who watched this, this might have been something new to learn. For those of you who did it, I'm quite sure this is definitely something which is interesting, something which you can definitely mention about, take screenshots, make a small report, because anyways, you need to delete the resource so that you're not wasting all your credits. So it makes sense to delete the resource. But once you're done using it, maybe you could, uh, look at the video if you want to later on and take some screenshots, create a quick one-pager report, add it to your resume, LinkedIn, wherever you want to. So, I mean, that's how people try to show that they have worked on AI. So, I think it's a good thing that might help you in your resume if you want to add that. Totally your call. Now, going forward, we have one slide to cover before we start the object detection. That's the second practical for today. Uh, we might overspill by 10 to 15 minutes with a break today because, as we're doing the practical, I hope this is getting interesting for many of you. And for those of you who are watching, again, you always have the opportunity to do the same thing again by looking at the video. The next is Azure Object Detection. So custom vision on Azure allows users to create object detection models with minimum deep learning expertise and fewer training images. Users must upload and tag images, train the model and publish it. So we are just going to upload the images and we are going to do the tagging. We'll also obviously have to train and test. We are not going to publish it. You can if you want to, but again, who would want to spend money on this for learning? I'm not sure many of you. So we'll skip the publishing part for now, though that could also be covered in the free services, but not in the scope of this fundamental series for sure. The tagging should ensure sufficient images of objects in question and bounding boxes are defined tightly around each object. After training, the model's performance is evaluated using precision, recall, and mean average precision. Once satisfied, the model can be published to the prediction resource. In simple words, what we are doing over here is, uh, obviously, we're going to do, object detection. So we are ready to explore it. Let me quickly share my screen again where I have my custom vision.ai open. So this is one of the projects that is already there. I'm not going to touch it. We'll be creating a new one. Uh, you do not need to immediately delete it, Suhas. We could talk about that in the second half. So let's create another one. So this was classification where you are classifying. You upload an image and it will tell you if it's a lion, if it's a giraffe, or if it is an elephant. You could be using other images as well. And then it could do the same analysis for you. So a very quick test. Let's say, let me search for elephant. Okay. Let's say this. Let's say this. I get the URL to the image. I go into this model. I want to test it. So I go into a quick test, enter the URL to test it against. And there it is. The elephant is 98.7% probability. So you see these images are very different, right? From the data that we have given. Again, it's loading. It's a little slow. Not spend a lot of time on that. So similarly, we did one example, we did one, practical on classifying the animals. Let's do another one where we'll, just a sec, it's a little sunny out here. Okay, so we did one on classifying the animals. Let's do another practical where we will be looking at the road signs and we will be exploring object detection capabilities of custom vision. So all of you, please click on the top left and you will be redirected to customvision.ai/projects. From here, please click on new project. And from the new project, please give it a name. So let's say object detection cyclist pedestrian. Okay. So this model is for detecting cyclists and pedestrians. Okay. The resource is going to be the same resource, that's Custom Vision ECSGA workshop, but the project type is going to be object detection. So please be careful. Do not just click on create project. It is a little different. So it is object detection cyclist pedestrian. The description is this is a model for detecting cyclists and pedestrians because that's the image set that I have. If I had images for anything else, I would have done the detection for that. And then the domain is general and we are ready to create the project. So I hope everyone is at this page. You name it because this is the detection project. Please make sure that the project type is object detection. We are not doing classification, we're doing detection. Click on create. And just within a bit, you'll be able to see this has been created for you. Now, the working of this is very different. You can upload all the images at once because you need to do tagging of image one by one. The maximum size of an image allowed on this is 6 MB. So if you have data that is greater than that, for my example, you won't. But let's say if you have data that is greater than that size, in that case, you would have to, uh, you would have to perform some pre-work on that to get it to a smaller size. So you'll have to perform some pre-processing on that so that you could reduce the resolution before you could feed it into this model. So let us extract the road safety images and you'll see quite a few images over here. To be precise, you have, I don't know how many, 1, 2, 3, 4, 5, 6, 12, 15 images. No, 33 images. So you have about 33 images that you can add. and these images have pedestrians and cyclists in them. You could be creating a new model later in the day from your own images. Maybe you could play around that in the break if required, but I think this is good for starters. So just click on upload. It's going to upload all the images. Since they are not super high resolution, the upload is going to be fast. Just close this, and we'll have to go and we'll have to open the image and we'll have to start labeling now. This is object detection. We need to train it to understand what an object is. We are not putting everyone in the same category now, right? So please be careful. The way you perform the operations is going to determine how close results you're going to get. So please be very careful. If you if you go on the first image, you click on the screen and you start selecting this, you cannot start giving this a tag. If you give this a tag, your data is going to become highly inaccurate. Okay, so we only have to give 2 tags, because if you want to give any other tag, you need more images. So you need about 15 data points per tag. So the only 2 tags that I'm planning to give is pedestrian and cyclist. Okay, does that make sense to all of you? Give me a thumbs up. For this example, we are only, out of the entire images we have, we'll only select the area around the pedestrian and the area around the cyclist. Any human we see who's walking is a pedestrian. Any person who's riding a bicycle is a cyclist. As simple as that. So you go to the first person, you click on them, and then you type in pedestrian and click on OK. So now you've generated a tag. So with this person, you can see it says pedestrian. If you want to adjust the size, you could do it, but you do not have to, because the region is selected automatically and it is the right region that was selected. So I'll not play around with this. I'll stick to this pedestrian. I do not want to mess with this. Okay. Right arrow, go to the next image. Again, see, this is what is happening. If I select a part of something else, it's going to get confused. So be sure that you select the entire human, because if you don't do that, it's not going to give you the same results. And you do not need to create a new tag again and again. You could be using the same tag. So you see, I'm going to go close to this person and not the face. I need the entire, the entire body. And then we're going to select that to pedestrian. This person is again a pedestrian. I'm not going to select the shadow because probability of getting confused gets higher with that. And this is the same person. So I'm just selecting the pedestrian. Quite a few pedestrians over here. So 1, 2, 3. Please try and select everyone, and as much as you can, not a part of the body, to make the model, as accurate as possible. So that is pedestrian. That is another pedestrian. That is again a pedestrian. Nope. If you add a wrong tag, please rectify that. Okay, now this is the first time we are seeing a cycle. So let me add the tag cyclist. This is a cyclist. Cyclist. Cyclist and another cyclist. This is cycle. For this, I'll select the entire cycle. So cyclist. Again, cyclist. Maybe over here, I might want to adjust a little by showing the entire face. So certain images you might not have to edit at all, and certain you might want to select the region. Again, for now, it might not have a very huge impact, but yeah, if you see your model is not giving you the desired threshold values that you need, it's not giving you the confidence that you need, by all means, you could go and do this. Okay, this entire thing goes to the cyclist. There's a cyclist, there's a pedestrian, there's a cyclist, another cyclist, 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 and another one. Mhm. And there we have a pedestrian. We no, wrong tag. Cyclist, 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 pedestrian, 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 and I am done. I know this did take some time for me to get all the images. Well, I can't see my images. What happened to my images? Let me refresh this. There, all my images have been tagged. So I can click on train and we'll be going for quick training. Now let's just wait for another 5 minutes or so when this gets trained. And after 5 minutes, we'll be able to supply any URL to this and it will be able to predict if someone is a pedestrian or if they are a cyclist. And it will tell you what is the confidence. So look at the difference. The first project that we created was classifying animals, where we gave in our own images and we trained it saying, hey, this is a lion. Hey, this is a cat. Hey, we didn't do it for a cat, but we did it for a lion, elephant, and for a giraffe. And for object detection, we uploaded about 30 images, 33 images, and told it that, hey, this is what a pedestrian looks like. This is what a cyclist looks like. So now let's say we want to use this model. The model, let's say if it's used for a car, the car will be able to detect if there's a cyclist in front of it or a pedestrian in front of it. I'm just giving an example of a use case where this could be useful. If all of you understand this, irrespective of doing the practical along with me or not, give me a thumbs up. I do understand the fact everyone might not be doing the practical right now. They might do it later on. That's fine. But if you understand this, give me a thumbs up. I want to see everyone's active. Okay. Let's see what's up in chat. Okay, things are going fine. Is everyone done with starting the training? Okay, you're still tagging. Take your time. Take your time. I've got 19 tags for pedestrians. I've got 16 for cyclist as well. Some images contain a cyclist and a pedestrian, so they might be overlapped. That's absolutely fine. So once you launch the training, go into the performance and wait for the training to finish. It might take a bit, but once it's done, we'll be good to go. Till then, let me find a couple of images on Wikimedia. This might be an image I might want to use. Yeah, page size, medium should work. Let's start with something basic. Oh, sorry. So model is still not trained. We'll wait for it. Might take some time. Okay. So you guys do not need to delete the resources immediately. We are well in the free, credits limit, but I'll talk more about it in a while, because I first want to finish with this, quick practical that we have, and then I could suggest some ways on how you could be, because it's a very common asked questions. A lot of students ask me, they've asked me in the past that, we have worked on so and so project on the cloud. How can we showcase that on, our resume? How can we showcase that project on LinkedIn? And the best way to do it is take a couple of screenshots of what you're doing today, put them in a Word doc, write a one-pager document on what you have done, how you have done it, upload that, as a project on LinkedIn. When you upload a project category on LinkedIn, you have an option to upload, one of the PDF files. Just do that. It could be really helpful. Uh, so it's taking some time, but obviously it's custom object detection. So that's what I expect out of it. Maybe another 4 or 5 minutes at max. Should be done before our break. So what happens is, like, when you look at these images, you realize that, you work with these, you find that this might be working, this might not be working. And when you realize information of that sort, you test for the performance of iteration 1, iteration 2, iteration 3. And when you feel that, every time you are training it, it is getting better or it is getting worse, when you feel that you are ready to hit the threshold, that's where you can start with the deploy. You won't see the deploy for now because, again, it's still not deployed, but the moment it is done, you'll be able to see it. And as far as if someone else wants to test it, what you could do is, I'll upload the videos before midnight today, so that if someone wants to, use it later this week, you can. You can create new models for, let's say, a car. Try and get the common images you can for the car, and for, let's say, for a Tesla, for a Toyota, for maybe, 15, 20, 100, 50 cars, maybe use 500 images, create a model. It will be more realistic. Provided with any picture, it will be able to tell you what is there in the picture. Uh, I have a question in the chat. Is the process manual? No. When you upload the images, there's a option of auto tagging. The reason I do not use it is because automatically it can use any tag it wants, right? So it could have so many options. But here, this could be a person, this could be, a male, this could be a female, this could be, tagged as a person, this could be someone who's posing, this could be a bag. But I do not want all these tags, because my goal for creating the model, we need to understand why I'm creating the model. So this model is for road safety. So if a car is driving on the road, for example, it should be able to detect who's a pedestrian and who's a cyclist. Let's say if this was the use case. So when you want to be specific, you do not want to use any sort of automation around, you know, the model detecting itself on what is there in front of it. So you want to do that process manually, where you are like, hey, this is what you are, this is what, this is an example of the image, something of that sort. By the way, you guys can check if anyone's model is trained. You can let me know. It's taking slightly longer than I expected. Is anyone done training the model, or is everyone in the waiting phase where you're waiting for the iteration 1 to complete? So Preetham is waiting, Suhas is waiting, Abu is also waiting. So I guess, yeah, most of us are waiting. Gautam is also waiting. 10 to 15 minutes for this is absolutely normal. I mean, that's absolutely fine. I won't be surprised on slow days if it takes like 20, 25 minutes as well. But I don't think it should take that time. We'll wait for another few minutes and see. If it is done, great. If it is not done, we'll look at it after the break. But if it is done, I might overspill by 5 to 10 minutes. I hope you guys can shorten your break a little. By the way, how many of you are liking this? I mean, because this is definitely new for a lot of you. Uh, how many of you are finding this interesting? That's the question I want to ask. Okay, that's nice. Okay. Well, uh, one thing about the attendance, we'll take the attendance at 1 p.m. because I do not want the attendance to be in the middle of the content. We have quite a few things that we have to discuss, and then it gets a little distracting when we take the attendance in the middle. That's why attendance is something which will take sharp at 1 p.m. So all of you, please be back by 1 p.m. It's important for us, or you could stay in the call itself. That's fine. If you join by 1:10, 1:15, you'll still see the same link. I won't share the same link again and again. Once I'll share it at 11. Once I'll share it at 1. The second time I'll share it at 3, so that nothing in between, no distractions in between. You need to fill that for getting the certificate. That's a requirement of ECSGA. Can't do anything about it. So that's nice that you guys are, liking it. It's nothing difficult, When we hear the term machine learning, for many of us who are new to this, we feel that, it's something which we might not be able to do. We think of it as something impossible to do. But by doing this simple practical, by all means, you can, if you're talking to someone in an interview, you're talking to someone in general, you could go to them and you could tell them that, hey, I have worked in machine learning on cloud. I know how to train a model. Now you know the terminology. What is a model? You know what is a training set. You know what is a label. This is the terminology that is generally expected. When someone might be offering you an entry level job in machine learning, artificial intelligence, they do expect you to know this terminology. So it's definitely a plus point in addition to the certification. So, and as I've already said this before, I'll say it one more time. AI-900, the easiest certification to give in Azure. You can be a totally beginner on cloud, spend 20 hours, you'll definitely be at a very, very good spot with very, very high chances to crack it if you study everything that is there in the documentation. Or if you are someone who's already worked on cloud, I would say, 15 hours, 10 to 15 hours is more than enough. If you're someone who's already worked like on Azure specifically, maybe just 4 to 5 hours reading the documentation, because the certification will ask you simple questions. What is machine learning? What is artificial intelligence? Is this regression? Is this classification? Questions like that. Pretty straightforward stuff. They might ask you the names of the services. What does this service do? What is custom vision? And by now, for those of you who are doing it, great. For those of you who are just watching me do this, you will be able to, uh, you will be able to at least talk about it or confirm that yes, by now you know something. And just as a clock strikes 12, my model has been trained. So I think now is the time where I could be passing in an image and put this to test. Let's see how it goes. So I've uploaded this image. Let's see what comes back. So this has detected the cyclist as 97.2%, 97.2% probability, which is very, very high. There's another cyclist. Now this is surprising. You see, within the image, there's a person who's riding a motorcycle, but again, since it's far, it does not look totally like a cycle, but it is somewhat similar. It has set the threshold to 52%. 26.7% for the pedestrian, because obviously a human is riding the cycle. So, for AI to show you something of this sort is totally natural. It's not something out of the ordinary. I'll say it is highly, highly accurate. Now, you could set your own limits. For example, anything below 77%, do not even show it to me, or anything below 70%. And this depends on model to model, so that you do not get a lot of noise. So if there's an image with a lot of people, now let me show you an example of that. Before I do that, I'm just sharing a couple of URLs in the chat, which you might need for the images. So this is one of them that I've tested with. I'm going to test with another one where I have a lot of people. So I won't be surprised if it gets confused. Let's see what happens. So you see, it has detected so many cyclists. So cyclists. Let me set the threshold to 71% so that I do not see a lot of noise. Or maybe let me set it to 86% because usually we might be working on higher thresholds. But let's say if 86 is somewhere close to being a realistic value, we'll see that it has been able to detect quite a few cyclists. And okay, so this person is detected as a pedestrian, which is not something that I expected. But that means we need more training data, right? Because this is a very low resolution, noisy image. So getting something of this sort is totally fine. I've shared the link in the URL so that you could test it. Let's say we further increased to 95%. So it has been able to detect two cyclists because again, the angle is different. We did not train it on a similar image. But if I lower the value, it'll be detecting so many people in the background. But since these people are not shown in full body, they're half body and we trained prediction for full body. That's why we are not able to find that. So that is absolutely fine. Let me go for another realistic image. So I would expect anything close to a 90% and above for this image for the cyclist. Let's see if it lives up to the expectation. So that is 99.6% cyclist. That is kind of nice. So again, sharing this with you. Let me get a few images with people and cyclist, or maybe two people and a cyclist or something of that sort. Let's say if we are on a road and we take this is obviously not the best image because again, not very high resolution and it has so much of noise in it, so much of data in it. Let's see. So we've got quite a few results. Let me improve this a little to slightly over 85. Pedestrian, pedestrian, cyclist. Not bad. If I lower the threshold a little bit, this becomes a cyclist as well because it's from very far. So I hope this makes sense to all of you. You could test around this workload. You could test around a lot of stuff. There's again an official test sample image that Azure has given to us. So I'll just try with that URL as well. And yes, so 98.2% pedestrian, 97.6% cyclist. It's a blur image, but at the same time, since it is better in resolution, it is still able to do the job, which is very, very accurate. And that is the power of using models. You do not need to do a lot of hard work, or things are done automatically. You could go, you can change, and you could work upon them. You can customize them. Just before you go for your break, I have a question from Alokik. If I edit the tag during training, then will the model retain according to that retrain according to that automatically? No. If you change a tag, you'll have to retrain your model again. So that is something you have to do. Now with this, there are values like precision. So this number will tell if a tag predicted by a model is how likely is it to be right, because they have done their own analysis. So according to them, it's 87.5%, which I say is not a very good value. So I will not put this model to production because two less images. You can't just train a self-driving car with 10, 50, 20, 100 images. You need hundreds and thousands of images and videos to understand different lighting, different scenario, different objects, so that you could get something which is highly accurate. But with this being said, thank you so much to all of you for staying till this part. I'll pause and then I'll discuss a few things with all of you. We'll continue within an less than an hour. So please